Welcome to the next episode of Thermodynamics. Today you are going to learn about the zeroth and the first law of thermodynamics. The zeroth law of thermodynamics describes natural flow of heat, which is always from system of higher to system of lower temperature. It is impossible for heat to go from cooler to warmer body unless there is a work done on the system. This statement is actually zeroth law of thermodynamics, which states this by using term thermal equilibrium, which is state of no heat flowing between two physical systems connected with path which allows heat to be transferred from one system to the other. Formal statement of this law says that if each of the two particular thermodynamic systems is in a thermal equilibrium state with another thermodynamic system other than one of these two, then these two thermodynamic systems are in thermal equilibrium with each other. In other words, if temperatures of these two systems T1 and T2 are both equal to T3, so both T1 is equal to T3 and T2 is equal to T3, then we have and can conclude then that T1 is equal to T2. This is how we can write zeroth law of thermodynamics mathematically. The first law of thermodynamics describes relationship between internal energy U, heat Q, and work W. It says that change in internal energy delta U of a physical system is equal to difference between received energy Q and work W, which is done on the environment. It can be expressed using this formula that delta U is Q minus W. So this first we have that is this zeroth law, and here is first law of thermodynamics mathematical expression. But it is very important to understand when of this each of these quantities is either positive or negative. So first we have that work is positive if it is done by a gas. It is if a gas does work on its environment, and work is negative if done on a system by its environment. There is also expression delta U is equal to Q plus W as another form of this law, but here we have opposite signs, meaning work is positive if it is done on a system by environment and vice versa. We will use the first formula, which says that work W is positive when a gas does work on this environment, so we will use this formula written here. It is actually a special case of conservation of energy law, where difference of internal energy appears due to heat exchange and due to work between observed system and its environment. These two cases are cases in which a system can change its internal energy. It is established by agreement that heat exchange Q and work W can be either positive or negative. We can draw a scheme on an example of a movable piston where gas particles are within it to illustrate when heat and work are positive or negative. So let's first draw here a small movable piston scheme. So we have a cylinder, and this movable piston has its lid, which is going up or down if we compress it in either of these ways. So this is lid, and this which we are using to push up or down, and so here it is movable piston. Heat is negative, so Q is smaller than 0 if system releases heat. Well, it is, so we have that it is negative when system releases heat. Heat goes out of the system gas releases heat, so heat Q is negative. And the other case is when heat Q is positive, meaning that this gas receives some heat is added to the system, so heat is here positive. And we also have for work, if work is done on the system, then it is negative. But if the system does this work, it is positive. We've already said this relation, this for work. This law of thermodynamics can be defined in words of perpetuum mobile, as perpetuum mobile of the first kind is not possible. So perpetuum mobile, or perpetual machine also called. Perpetuum mobile or perpetual machine is a hypothetical machine which would work forever without an outer energy source, a work which would have to be done. So perpetual machine of the first kind is a perpetual machine which would give more work than it would need for its machine work. This process would have to be cyclic to realize it, because its internal energy should be equal in the beginning and in any point of time of the process. So change in the internal energy of the system should be 0, and then apply the first law of thermodynamics, the delta U is Q minus W, and from this fact and from this first law of thermodynamics, as we've said here, we get that Q is equal to W, meaning that all the heat is spent on a machine's work. In spite of that, if heat was equal to 0, there will be no work of a machine, which brings us to the initial statement. So if we set that Q is 0, so there is no heat exchange, we get that work is 0. This means that perpetuum mobile of the first kind is impossible to build. Although this law explains even the impossibility of a perpetual machine construction, and at first sight seems to maybe perfectly describe what it is supposed to, it does not ideally explain this thermodynamical situation, because it cannot determine a process occurring in nature as reversible or irreversible. A reversible process is one which is bidirectional, meaning it can occur in both directions without changing anything else in its environment. Examples of such a process is constant transformation of potential energy into kinetic energy, and vice versa. Also, cycle processes in thermodynamics we are going to talk about are reversible. So we have a reversible process which happens in both directions. For example, we said transformation of potential into kinetic, and from kinetic to potential energy. And the second type are irreversible processes. So opposite process is an irreversible process, which is unidirectional because the system exchanges a certain amount of heat with its environment and the environment changes. Example of an irreversible process is case with two systems of different temperature, where the warmer one will always cool down and the cooler one will heat up according to the Zeroth Law of Thermodynamics. So the hot body will hand over a part of its energy in form of a heat, thermal energy, to the cold body. So the example of an irreversible process is heat transfer always from hot to cold body. This is a spontaneous reaction, which is, you can see, irreversible. It cannot spontaneously go in the other direction, that cold body hands over a part of its energy to hot body, unless some work is done. That's all for today. Now you can take a quiz to test what you've learned in this video. You can find the link in the description of the video. Thanks for watching and stay with us.